Hello, everyone. My name is Shravan Rai, and this is a presentation of my research proposal evaluating AI integration at a session layer for WebRTC-based telehealth platforms. I'll cover the problem, the literature, the gap in the literature, the research design, and the significance in the next 5 minutes. AI tools are being layered directly onto live clinical video encounters, ambient documentation, real-time transcription, computer vision, etc., all running on top of WebRTC platforms while a clinician is talking to a patient. The COVID-19 pandemic accelerated the telehealth dramatically. One academic health system saw a 30-fold increase in weekly telehealth visits. That created enormous pressure to deploy AI fast before the evaluation infrastructure existed to assess it. The core challenge here is documented repeatedly in the literature is benchmark performance does not predict clinical performance. AI tools that look good in controlled conditions often fall apart in real deployments. The problem is no published framework evaluates session layer AI across technical performance, HIPAA compliance, and demographic equities simultaneously in a live WebRTC encounter. That is the gap this study addresses. So the literature study has been organized into three themes. First, AI as clinical augmentation. From the research, we find that AI extends what clinicians can do. But deployment context is still an unresolved problem. Systems that perform well in benchmarks routinely underperform in clinical use. We see this in the ambient documentation literature. The note times drop, but accuracy gaps appear, and the language shifts away from the patient. Second, it's the session layer infrastructure. WebRTC imposes constraints that most AI studies ignore, that is, media server requirements, real-time latency variability, HIPAA compliance, etc. These are not optional considerations, they are architectural requirements. Third, equity and access. Rural patients, patients of color complete telehealth visit at significantly lower rates. AI trained on healthcare utilization data inherits that disparity before it's ever deployed. The organizing framework for the study is De Leon and McLean's IS success model. Each research question maps to a specific dimension, that is, system quality, information quality, user satisfaction, net benefits. The mapping makes the study testable and internally coherent. Now let's see what's the gap in the literature or where we can add value. So the SIME characterized that WebRTC's clinical architecture in without AI. Rajpurkar identified the deployment gap in the 2022 research without addressing real-time video. O'Day documented ambient AI scaling barriers in the most recent 2026 paper, and it did not consider the session layer analysis or disaggregated patient data. Every column in the equity dimension is empty. No prior study addressed it at all. Two gaps remain open. First, no study has concurrently evaluated all three dimensions in a live WebRTC encounter. Second, no published study has assessed AI transcription accuracy broken down by patient demographics within an actual telehealth encounter. We have made this study designed to close both these gaps. Here, we discuss the design methodology and design. The design is a single case embedded case study using mixed method of both quantitative and qualitative data. The four research questions that we have thought about, or I have thought about, is RQ1, answered through full mixed method design. Research questions 2, 3, and 4 carry a directional hypothesis tied to the quantitative strand. The research question 2 asks whether AI increases session latency to a clinically acceptable level. Q3 is whether ambient AI reduces node completion time and cognitive load on providers. Q4 is whether AI transcription accuracy varies across patient race, ethnicity, age, and primary language. From the data side, or the quantitative data comes from server telemetry, EHR timestamps, word error rate analysis, and a validated cognitive load instrument. Qualitative data with interviews with at least 20 clinicians across primary care, behavioral health, and specialty are planned. Both strands integrated at interpretation stage to produce the unified framework. Ethically, the study requires dual IRB approval, HIPAA-safe, harbor de-identification of all patient data, voluntary informed consent, and full disclosure of conflict of interest. So what are the contributions of this study? First, it produces the first empirically validated evaluation framework for real-time AI in live telehealth clinical encounters that directly addresses the deployment context problem that Raj Parkar and colleagues identified as the primary unsolved challenge in clinical AI. Second, it extends ambient AI documentation evidence from controlled ambulatory settings into a commercial session layer WebRTC environment. The findings from research published in 2026 are starting point, but this study tests whether they hold in the real-world deployment context. Third is it establishes that equity evaluation must be embedded in deployment phase architecture design, not detected afterwards, not appended as a patch, built from the scratch. The beneficiaries of this research are health systems that need deployment standards, platform developers that need benchmarks, clinicians who need tools that work, and patients who need the care. That's all my research. Thank you. And these are the academic references that I have used. Thank you.